Hi there. Welcome to Chapter 7 of your textbook. Chapter 7 is an introduction to the structured query language, or SQL. It is one of the most important chapters in the textbook. Now, SQL is very simple to learn. It has a very basic syntax, and we'll be going through several examples of SQL statements or SQL statements in this chapter. So it's important that you watch this video slowly if you want. You can feel free to rewind and go over some sections again. Also, note that I have updated these set of slides with many more slides. The original set has about 40 slides. This one that I'm going to present in this video has about 76. And I've uploaded the updated PowerPoint to Canvas, so be sure to download the new PowerPoint for Chapter 7 as well. One last thing before we go forward. This chapter is accompanied with a lot of practice exercises, and there's also an activity, a graded activity for you to complete on MindTap. Please be sure to go through at least a couple of practice exercises before going through the activity. Okay, that'll help you get a hands-on experience with the SQL statements. Okay. Another thing I'd like you to remember for this chapter is I'd like you to focus on the practical hands-on aspects of SQL and less on the theoretical stuff that the textbook might get into. So if there is something very theoretical that the textbook is getting into, you do not need to focus so much on that. Focus more on the practical SQL code that we cover. Okay, so with that, let's get started. So there are 4 categories of SQL functions, and if you are familiar with SQL or databases, you have probably seen the data definition language and the data manipulation language. The data definition language is used to create the database objects such as tables, indexes, views, etc. The data manipulation language is used to insert, update, delete, or retrieve data within the database tables. Transaction control language. Now, transaction is a logical unit of work, and the transaction control language controls how the transaction gets processed against the database. Data control language is used to define access rights to the data objects, such as giving specific users permissions to specific tables, etc. SQL is fairly easy to learn. It has a very small vocabulary set of less than 100 words, and differences in SQL dialects are very minor. So different DBMSs implement SQL slightly differently, but the differences are fairly small. Okay. So we'll cover, starting with the basics, select statement, delete, and logical operators, special operators, and some aggregate functions in Chapter 7. In Chapter 8, we'll look at inserts and updates. We'll also go through some data definition language in Chapter 8. So creating tables, creating indexes, views, etc. Dropping tables, etc. will all be covered in Chapter 8. We'll cover transaction control language in Chapter 8 as well. So commit and roll back. And we'll cover data control language in Chapter 16. So granting and revoking permissions. So a data type is a specification about the kind of data that can be stored in an attribute. For example, Age might have a numeric data type. Someone's date of birth might have a date of type, and so on. There are three fundamental types of data: character data, numeric data, and date data. Okay. Now everything in SQL is done through queries, so it's a structured query language. Queries can mean both questions as well as actions. So in other words, if you want to, for example, retrieve data from the database, that's obviously a query. But also if you want to insert data into a database, that's also referred to as a query. Okay. So here's the database model that we'll be using in this chapter. So you can see that we have a customer table, we have a product table, and a vendor table. Right now, a vendor can supply many products, and a customer can generate many invoices. So we have the invoice table as well. And an invoice can contain many line items, right? A product can be found in many line items, right? And so on. Okay, so fairly easy to understand database model. Let's start by looking at the select queries, right? So each select query performs a specific function. Now this is the general structure of the select query. We have select from where, group by, having, order by. Now every select query does not need to have all these clauses, right? For example, you might see select queries with just the select from where clause, right? So the group by, having, and order by are more complex select queries, and we'll look at them later in this chapter as well. But for now, you should remember this sequence. In fact, you should probably memorize it. It's fairly easy to remember. Select from where, group by, having, order by. Okay. So if you are interested in becoming a database administrator, or you have an active role in querying or creating queries, then you should remember these 6 keywords. Okay. Now the select query specifies the columns to be retrieved in the form of a list, right? So we can have the easiest way to understand this is to look at an example. So here's an example. If we say select star from product, that means select all the columns from the product table. So this will select all the columns in the product table and all the rows. So we have not specified any limiting criteria. The where clause will let us specify limiting criteria that limits the selection to particular rows that meet that criteria. And we look at that later on. But for now, this is the most basic SQL statement, right? Select star from product or from any table. Now notice that there is usually a semicolon at the end of every SQL statement. Also, this entire statement can be written on one line. It doesn't have to be split up into multiple lines. However, it makes it very easy to read if you format the SQL statement along different lines and use spacing such as tabs used here, right? The code becomes very readable and easy to understand. Let's take a look at another query. We have here select pcode, pdescript, pprice, and QOH. QOH is quantity on hand. Okay. So in this statement, we are specifying that we want to select 4 columns, 1, 2, 3, and 4. These are the 4 columns that we want to select from the product table. So the result of this query is this table here. Here we see we have the 4 columns, and once again we have all the rows from the table because we have not specified any limiting criteria in the where clause. Okay, so we'll look at the where clause soon. Now here's another example of labeling one of the columns as unit price, right? So if you see columns, column names such as P code, you may not know what that means. In the previous example, description is labeled as P descript, right? Price is labeled as P underscore price. Quantity on hand is labeled as P underscore QOH. To give more understandable column names, there is different ways of doing it. So there's 3 different ways that's shown here. The first way and the most readable way is to say P underscore price as, and then the column name in quotes. Okay, that'll label that column as whatever you have in the quotes. A second way of specifying column names, or also known as column aliases, is simply using as and then giving the name, right? So as description. The third way of specifying the column alias is to simply put a space between the actual column name and the desired alias. Okay, so this labels QOH or quantity on hand as simply QTY, right? This labels P descript as description. Now we can also do arithmetic operators within SQL statements. So for example, if you want to add 2 numbers from 2 different columns, you can use the plus operator. If you want to subtract, you can use the minus, and so on. Okay. Now, aside from numbers, you can also do date arithmetic in SQL. So it is possible to sort of add days, subtract days, and so on. There are examples of this in the textbook. You can look at a couple of examples there. It's very easy and intuitive to understand. Sometimes you want to list unique values in a particular column. For instance, you might have a table which lists several addresses of customers possibly, and you want to see what unique cities are there in that table. So you don't want duplicate cities, you don't want a list of all the cities including duplicates, but simply the unique cities that are there in that table. In that case, you can use the distinct keyword, and here's the syntax for it. Select distinct vcode. In this case, we're using a vcode from the product table. So select distinct vcode from product. And that produces all the unique vcodes that are there in the product table. Now you'll see that this value is null. So null counts as a value, and therefore it appears in the results as well, because there are some null values in the vcode column. Okay. The from clause of the query specifies the tables from which the data has to be retrieved. Okay, and there are also different types of joins in SQL. We have inner joins, outer joins, natural joins, and so on. Let's take a look at these with examples. in this example, we're seeing the natural join. So just recollecting our database model, we have two relations or two tables called customer and invoice. One customer can generate multiple invoices. And let's say we want to find out all the customers who have generated invoices along with the invoice number and the invoice date, right? So in that case, we would need to pull 4 columns of data: customer code. Let's say we want just the customer last name. If we want to add first name, we could add that as well. And we want the invoice number that the customer has generated and the dates for those invoices. So here is the SQL syntax for that. We say select cus_code, customer last name, invoice number, and invoice date from customer natural join invoice. Okay, now natural join will join on the common attributes that are there in both the tables. And here you can see that the primary key, customer code, is a foreign key in the invoice table. So when this SQL is run against the database, the DBMS will match on customer code, okay, because that's the common column across both tables. And it will pull this information, these 4 columns that we have asked it for, right? So it'll say customer code. So we get customer code, customer last name. Then it matches for each customer in the customer table. It matches at the customer code in the invoice table and pulls all the invoices for that customer code. So customer code 10,011, for example, has 3 invoices, right? 1,002, 4, and 8. And the invoice dates are as shown here, right? Customer code 10,012 has only 1 invoice in the invoice table, and that's with invoice number 1003 on 16th Jan, and so on, right? So we get 4 columns returned here, matched on the customer code, and we get the invoice number and the invoice date. So this is our result for this query. So notice that the way we created the link between the two tables was through the foreign key, right? So if we had 2 tables called vendor and product, for instance, right? One vendor can supply 0 to many products. You can see that the primary key, vendor code, is the foreign key in the product table, right? So in the vendor table, we have several vendors listed, right? We have data on several vendors. Each vendor has a vendor code, right? In the product table, we have several products listed, but then we are also linking the product table to the vendor table using the vendor code. So each product has the associated vendor code from where that product is coming from. Right? Now, there might be products that have no vendor codes. Vendor code is null. Why is that okay? Because as you can see here, the cardinality here is that vendor can supply 0 to many products, right? And a product can be supplied by 0 to one and only one vendor. So because we can have products in the table that are not being supplied by any vendor in the database, we could, for example, be manufacturing those products in-house. So those products would still be stored in the product table, but their vendor code would be null. Okay, and so this is perfectly okay. However, recall back to referential integrity. If you do have a vendor code here in a product, then it has to be a valid vendor code that exists in the vendor table, right? That's recalling back what we've previously learned about referential integrity. Okay, so when these two tables are joined, the join takes place on the common attribute, which is vendor code. Okay, so that's the linking attribute for these two tables. So now there is also the join using syntax and the join on syntax. Most DBMSs use join on, and you will not see join using used in many places. Okay. So again, these two queries would join the two tables. We look at examples here, but the syntax for join using is select from table 1 join table 2 using the specific column that you want to join with, right? And that common column must be placed in parentheses, and it must exist in both tables, right? The join on syntax is also very similar. Select from table 1 join table 2 on, and then the join condition. This join condition can be, we'll see an example of that. So here's an example. We're joining the vendor and the product tables using the common attribute that exists in both tables, that is vcode, right? And we want 6 columns. We want pcode, description, vcode, so the product code and the product description. Then we want the vendor code, the vendor name, the vendor area code, and the phone number. Okay. From product join vendor, so join vendor using vcode. In parentheses, vcode exists in both columns, right? And so we get back this set of results, right? These are all the products that are being supplied by vendors. Now let's take a look at an example with join on. Now in this particular example, we are actually joining 3 tables, right? And what are the 3 tables? We have invoice, line, and product. Ignore the vendor table here in the screenshot. Okay, so we're joining 3 tables, and the syntax to do that is to say select something something from table 1 join table 2 join table 3, right? And the first join takes place between table 1 and table 2 on the common attribute between those 2 tables. What's the common attribute? It's invoice number, right? And the join between table 2 and 3 also takes place along the common attribute in those tables, and that's pcode. Okay, so here we say select these columns, and we'll come back to the select columns clause. Select something something from invoice join line, so invoice join line on invoice number, invoice dot invoice number equals line dot invoice number, right? This is the condition that we are joining on, right? So join on takes the condition, and this is the condition. And then we join with product, so join product on line.pcode equals product.pcode. Line.pcode equals product.pcode. All right. Now notice here that in the select clause, we have specified the table name here, invoice.invoice number, product.pcode. Why is that? Because we are specifying that pull the invoice number from the invoice table. Invoice number exists in both the invoice and the line tables. We're asking to pull it from the invoice table. Similarly, product.pcode, meaning we're asking pcode from the product table. P description, line units and line price. Now, P description only exists in the product table. Similarly, line units and line price only exist in the line table, right? So we don't need to give it the fully qualified name. This here is called the fully qualified name for that column, right? Where we have table name dot column name. Okay. So this is how you use join on, right? Join on condition, right? Table 1, join table 2 on condition. And if there's a third table, you can add that to the list as well. Join third table on condition. Okay. And so this is the result of that table. Here we see all the invoices, the products, and the line, the invoice lines, right? Next, we look at outer joins, cross joins, and recursive joins. Recursive join is a query that joins a table with itself. And we've looked at a recursive relationship before. That's the employee table, and one employee can manage. So it was the managerial relationship. One employee can manage 0 to many employees, other employees, and one employee can be managed by 0 to 1 manager, right? Outer joins return not only the rows that match the join condition, so rows that meet the join condition, but also returns those rows with unmatched values. All right. And there are 3 types of outer joins: left outer join, right outer join, and full outer join. Okay, we look at examples from all 3. A cross join is also called a Cartesian product of 2 tables, and we won't be looking at an example here, but it simply returns the full product of the 2 tables, basically. Okay. Now, there is this concept of an alias that you should be aware of in the syntax. An alias may be used to identify the source table from which data is taken. Here's an example. Select something something from product P. Here P is the alias for the product table. Product P join vendor V. Here V is the alias for the vendor table. So in subsequent code, you can refer to the product table using just the alias P. For example, we say from product P join vendor V on P.vcode equals V.vcode, right? Instead of saying product.vcode equals vendor.vcode, we can simply say P.vcode equals V.vcode, right? So you can see that aliases are useful because they improve the readability of the code, right? It's easier to read this code with short forms or aliases, right? So that's all the idea of alias is. Now let's take a look at some examples for outer joins. Okay. So here we have a left outer join. Now in a left outer join, the left outer join returns all rows in the left table with unmatched values in the right table. Okay, so even if there are unmatched values in the right table, all those rows in the left table still get returned. And what is left and right? It's simply the first table that you specify in the from clause. That becomes the left table. And the second table that you specify in the from clause is the right table. So the left outer join, vendor left join product, here vendor is the table on the left. This query will return all the rows in the vendor table, even those rows that don't have any matching products in the right table, in the product table. Okay, again, the left outer join will return all the rows in the left table, including those rows in the left table that do not have any matching values in the right table. That's called a left outer join. If you think of it in terms of a Venn diagram, then a left outer join returns not just those matched rows in the left table, it also returns those unmatched rows from the left table. Okay, so you can think of the left outer join this way in terms of a Venn diagram. Okay, let's take a look at the syntax for a left outer join. The syntax is select pcode vendor.vcode vname vendor left join product on vendor.vcode equals product.vcode. Right? So again, we get back all the vendors, all the rows in the left table, which is the vendor table, even those that don't have any matching products. Right? These rows, for example, don't have any matching products. They still get returned in our results. In a normal join, a natural join, not an outer join, in an inner join, we would not see these rows. These rows with no matching p-codes would not get returned. Okay. So these are vendors who exist in our database in the vendor table, but they don't have a matching product that they are supplying. Okay. So again, left outer join returns all rows in the left table, including those with unmatched values in the right table. And what is left and right? Well, left is simply the table that you put first in the SQL query. Right is simply the table that you put on the right side, the second table in the SQL query. So that's left outer join. Now you can imagine what a right outer join would be, right? It's the complete flip side of the left outer join. So a right outer join returns all rows in the right table, including those with unmatched values in the left table. Right? So if we say select the same columns as before, vendor right join product, here again our left table is vendor and our right table or the second table is product, but we are doing a right join. In other words, we would get back all rows from the product table, even those rows in the product table that do not have any corresponding matching rows in the vendor table. Okay, and you can see that in the result here. We get back all the products, even those products that do not have any matching vendors in the vendor table. So that's a right join. Let's look at the syntax again. Select P-code, V-code, and V-name from vendor right join product on vendor.bcode equals product.bcode. Okay? So we get back all rows from the right table. The right table is simply the product table here. Even those that do not have matching values, matching rows in the vendor table. Okay, so that's right outer join. Now you can imagine what a full outer join would do, right? A full outer join would return all rows. A full outer join, that is the third type of outer join, returns all matching rows, also those that are unmatched in either table, right? So we get back not only all products, right? We get back all products. We also get back all vendors, right? We also get back those products that have no matching vendors, right? And we also get back those vendors that have no matching products. Okay. So let's go over the syntax. Select pcode vendor.bcode vname from vendor full join product on vendor.bcode equals product.bcode. Okay. So that's the full outer join. Now you might be wondering where would you need such results? Well, the why is a question for later. As you join the workforce and you begin to work in SQL and in databases, you will find scenarios where you need to do a left outer join or a right outer join or a full outer join, right? Or an inner join. So there are many scenarios in which these queries become very handy. Okay. Now let's look at the recursive join. Before we go into the recursive join, let's revisit the employee table. So here's the employee table. It has several columns. Let's look at them one by one. So we have the employee number, which is the unique identifying number for the employee. It's the primary key. We have the employee title, last name, first name, middle initial, date of birth, hire date, area code, phone number, and notice we have the employee manager field here. Employee manager specifies who is the manager of this employee. And guess what the employee manager is? It is an employee number, right? All these are nothing but employee numbers. They are referring to this very column here in this very table. For instance, the employee with employee number 101, 102, and 103, all these three employees have the same manager, the employee with employee number 100. This person here, right? The employee with employee number 100 does not have any manager. Okay. Now, whether or not this is a realistic situation or not is a matter for another discussion, but here we're simply looking at how do we do a recursive join in SQL. And again, you will see situations where you might need to do recursive joins. Okay. So let's pay attention here. The employee with employee number 104 has as their manager the employee with employee number 105, this person here. Okay. And so on. So here's the syntax for a recursive join. We say select e.employee number. So remember we were discussing aliases. Here E is an alias for the employee table, E dot employee number, E dot employee last name. So employee number, employee last name, E dot emp manager, meaning who is the manager of this employee, and then M dot employee last name, where M is the alias for a second employee table that we are referencing in the same query. So notice this is the way to do a recursive join, is to have two aliases. The first table we use is the employee table with alias E. So employee E join employee M on E dot emp manager equals M dot emp number. Okay. Notice here we have E dot emp manager, meaning who is the manager for the employee, and the employee number from the manager M table. Okay. So this is the way to do a recursive join, and here are the results of this recursive join. We get back all those employees that have managers, right? And we get back the manager employee number and the manager's last name, along with the employee number and the employee last name. Okay. So again, pay attention to the syntax, particularly the use of employee E join employee M. And what are we joining on? We want the E dot emp manager, meaning the emp manager field in the employee table, to be the same as the M dot emp number field. Okay. So that's a recursive join. Now let's come to the order by clause, right? So we have select from, possibly a where, and then an order by. An order by does exactly what it sounds like. It orders the results in the query, the results of the query, in a certain order by the column or columns that you specify. And it can be in ascending or descending. The default is always ascending order by the column that you specify. Okay. So let's take an example here. Here we have select P code, description, quantity on hand, and price from the product table and order by product price. Right, so you'll see that the results are sorted in ascending order of P price. Okay. The where clause is used to add restrictions to the select statement that limits the rows returned by the query. Right, so just like the select clause selects specific columns or fields that we want to return, the where clause specifies the conditions, meaning the rows that meet those conditions, only those rows would be returned by the query. Okay, so here we have select from where condition list, order by certain columns. Okay. Now you can include all types of conditions in the where clause. For example, you can have numeric conditions, character-based conditions, even date conditions. So where certain date greater than certain other date, and so on, right? Let's take a look at a few examples. So before jumping into the example, here we have the different comparison operators that can be used in the query. So we can have where something is equal to something, something is less than something, and so on. right? The not equal to is either this symbol or this symbol, depending on which DBMS you're using. Okay. So again, let's take a look at an example here for the where clause. So here we have a very simple example where we only want products from a certain vendor, right? So the question we're answering is, what products are supplied by the vendor with vendor code 21344, right? So we say select description, quantity on hand, price, and vendor code from the product table where V code equals 21344. So we get back only those products that are being supplied by this particular vendor. And there are 3 products here. We get the information on those 3 products. Okay. Similarly, you could have all products that are not from a particular vendor. So this is the not equals operator. You can have a different criteria. For example, all products whose price is less than or equal to $10. So this is the less than or equal to 10. So less than or equal to operator, and so on. Okay. Now you can also have logical operators. So say, for example, if you want to have more than one condition, this here is one condition. If you want to have more than one condition in the query, right? You want to return rows that meet multiple criteria, then you can specify these criteria using logical operators. So the AND operator can be used to specify both conditions should be met, right? Condition 1 and condition 2. The OR operator can be used to specify 2 conditions, either of which is true, then you want to return that row, right? So condition 1 or condition 2 can be specified using the OR operator and the NOT operator. So where condition 1 not true or not condition 1, and so on. Right? Let's take a look at a few examples. Now your textbook also makes a note of some old style joins that are generally not recommended, and these are not used. Right? But we've already looked at the proper syntax for joining tables, and that's using the join on operator. Okay. So here's an example of an OR operator, right? So in this case, we're saying, give me product description, quantity on hand, price, and vendor code from the product table for these 2 vendors, right? Both of these vendors. So where V code equals 21344 or V code equals 24288. Right? So we get back data on both the vendors. Here's an AND operator, right? Where the price is greater than 100 and the quantity on hand is less than 20. Right? So here we get back those products where both these conditions are met. The price is greater than 100 and the quantity on hand is less than 20. Okay. Now you can always use parentheses to specify more complex conditions. For example, in this condition we have where, so where vendor code equals this or this and the price is greater than 100. Right? So notice the use of parentheses here. Right? It's just like you would do in algebra. Right? Notice that without the parentheses, you would not get back the correct results. So this use here without the parentheses is incorrect. Okay? So you always want to be clear about what conditions you want to specify and how you should specify them. Okay? Now there are also other special operators. So for example, we have the between operator in SQL. If we want to specify a range of values, so between 0 to 100, then we can use the between operator. The between operator can also be used for two dates, not just numbers, it can be used for dates as well. So between, for example, 1/1/2000 and 1/1/2001, right? Things like that. The in operator is used to specify a set like list, right? Where you want to find out all those rows that have certain things in a set of values, right? And we look at an example to make it more clear. The like operator is used to match text or characters. The is null operator is used to simply say where certain values are null. Return me those rows where certain value is null. And the not operator is just like the opposite of the equals operator, where something is not true. You want to return rows where a certain condition is not true. Okay, so let's take a look at these examples. Here we see price between 50 and 100. So you have to use the between operator with the and keyword, right? Between this and this. Okay. Here is the in operator, where we code in this particular list, and you can have more than two values. You can have any number of values here. So the in operator works just the same as the or operator. This query is the same as this query. You'll get back the same results, right? The like operator is used to do some string matching. So if we say where we contact like Smith %, the % is a wildcard character here, where it'll return everything that starts with Smith and has anything after Smith, right? So for example, here we get Smithson back as one of the results, right? So one thing to note is that the % operator also includes spaces, right? So you could have Smith space, and that would also get returned. You could have Smith 1, 2, 3, and that would also get returned in the results, and so on. Okay. Now, some DBMSs are case sensitive in that if you say Smith as in S capital and the rest of the letters small, it would only match exactly on those letters. Other databases are not case sensitive, where it would look for Smith in any case. So the S could be small and it would still get returned in the results. To bypass this problem, one of the things that you can do is convert the column to uppercase first. So here you see we are saying upper V contact, meaning get the V contact column, which is this column here, and convert it to uppercase. Convert everything into uppercase first, and then compare that to this string that I'm specifying here. Okay. So upper V contact like Smith. Right, so it'll convert everything to uppercase first before making the comparison. Okay. Now here's the not like operator. So just like we have like, if we do not like, then we'll get back everything that's not beginning with Smith. Okay. Here's the is null operator. We want all the products where V code is null. So we get back these two products. Okay.